This practice problem says, what reagents are needed to bring about the following transformation? So it's essentially a synthesis problem. And whenever we have a synthesis problem, we're going to ask ourselves two key questions. Has the functional group changed, and has the carbon skeleton changed? If we look at the starting material and the product, they're both alkenes. But there is one significant difference, and that is that we have added a methyl group to the end of the chain that's coming off of the ring. So the fact that there is an additional methyl is a big red flag. Anytime we add a new carbon-to-carbon bond, there's really only like so many reactions that we know that can do that. And so in this instance, one way that we can do that is via the alkylation reaction that uses an alkyne. And so we know now there's like a certain intermediate that we have to look for in the synthesis. And that helps us a lot because it kind of gets us thinking about, how do we make an alkyne? How do we get an alkyne to a trans alkene? So this practice problem encompasses a lot of alkyne addition reactions and other types of reactions that alkynes will undergo. So let's take a look at this synthesis and kind of narrow our answer choices down. All right, so the first thing that we're going to do is take stock of the starting material. There's a 2-carbon chain coming off of it, and this one has a 3-carbon chain coming off of it. So again, just kind of recognizing that additional methyl group that's present. We know that we can do alkylation via a alkyne, and so we can kind of think about what alkyne would we need in order to add a methyl group. So the key alkyne is this one right here. And now we kind of have to think about, all right, how do we get to that alkyne from our starting material? And then how do we take that alkyne and make the product from it? So let's kind of start with the alkylation, because we know that needs to happen after we make an alkyne. So alkylation would let us add one methyl group to that alkyne. So that gets us to kind of a place where we've got all the carbons that we need now. And then we can kind of think about, all right, we know ways to convert alkynes into alkenes. In order to get to the alkyne, we have to think about ways to prepare alkynes. And kind of one key way that we talked about doing this was via double elimination reactions, where you have at least 2 bromine atoms attached. This is a multi-step synthesis because there's lots of things going on, making an alkyne and then converting that alkyne back into an alkene, the alkylation reaction. So lots of different things happening. Notice too that when I'm solving this question, I'm kind of thinking about the synthesis first, and I'm not really worrying about the answer choices. So I'm going to kind of think through this synthesis and be like, how do I do it? And then I'm going to look at my answer choices and see which ones can work. So to do step number 1, I'm going to number each of these steps. We're going to need to brominate. And so we learned how to do that in halogenation reactions. So we can do Br2 and like an inert solvent like carbon tetrachloride. Okay, we could also use chlorine. Either one would work. So that gets us to the dihalide. And then from the dihalide, we can use excess strong base. NaNH2 is a common one. And that is going to do the double elimination that's required to make our alkyne. So that gets us to the terminal alkyne here. Actually, let me adjust what I just drew. That gets us to this molecule, this alkynide. So it's a strong nucleophile / strong base. So this is kind of the key reagent that we need for the alkylation reaction. We only need to add 1 carbon. So we can use something like methyl iodide in order to do that. Okay, and remember this is an SN2 reaction. And you have to use like very sterically unhindered alkyl halides in order to favor SN2 over E2. Last step is once we have that alkyne, how do we get it to a trans alkene? So there's a bunch of different kind of reactions that we talked about that add hydrogens across pi bonds. And the one that will allow us to convert an alkyne into a trans alkene is the dissolving metal reaction, where you use sodium and liquid ammonia. So we've kind of thought about how to do this. Now let's take a look at our answer choices and see which ones could be legitimate. In A, we have a good first 2 steps, but step number 3 is problematic. Step number 3 would add too many carbon atoms, so our alkyne would be too big. In answer choice B, we're good through these first 3 steps, but when we get to the last step, Lindlar's catalyst is where we go wrong, because Lindlar's catalyst will bring about a cis alkene as our final product. Answer choice C looks good based on what we thought throughout the whole reaction, so I'm going to give that one a check. D, we're good through here, but then 4 is where the problem occurs. Again, this would take us to an alkane. We found the wrong reagent to add hydrogens across the pi bonds. Answer choice E, the first reagent is incorrect. That will only add 1 bromine atom to the alkene and not the 2 that we would need for a double elimination. So after looking at everything, only answer choice C is a viable option for this transformation. So answer choice C is the correct answer.